Hello there, ROS developers, and welcome to this live class number 106, where we are going to be talking about ROS2 services. So, let's start. So, hello everybody, ROS developers, my name is Alberto, and today we are going to be doing live class number 106, where we are going to be talking about ROS2 services. We are going to see some examples of how to create a service server, a client, also some command line tools, and some particularities and differences about services with respect to ROS1, to traditional ROS. So yeah, hello everybody, welcome everybody. I hope all of you are doing fine. Let me know, as always, if everything is fine. Video and sound are good. Can you see me and hear me properly or not? And if everything is fine, we are going to start straight away. So I'm not going to lose any more time. Yes. Okay, so hello. I can see here Del Capute, Felipe Rivas, Munim, Raihan, Engineering Nations, who says audio and video are good. Everything sounds good, says Daniel Molina. Excellent, then let's go for it. So, as always, I'm going to start by sharing with you guys here the link to the ROSject of today. So let me right now jump to my computer screen. So I will see you in a moment. Bye bye. Then let's see. So here I am in my ROS.ds main screen. So let me refresh here so that the ROSject of today's class appears. I don't have it here. Okay, I guess this might be... Okay, let me come here real quick so that I can get... Let me see. There we go. Yeah, this, I am safe to remove it. Close. There we go. Now I should get it. Okay, excellent. So here I have it. Then let me grab the link and share it with you here in the chat. Where do I have the chat? Here. There we go. Okay, so here I have right now shared the ROSject with you guys. So next step, as always, is to copy. You can click on directly on the link. You can copy the link and paste it to the browser. In any case, you are going to need to be logged into the ROS Development Studio. So in case you already have an account, just log in. In case you don't have an account, just create an account. It's completely free, and it's going to take you only a few seconds. Then once you are logged in and you click on the ROSject link, you are going to receive this ROSject here, the same as I have. ROS Developers Live Class number 106, ROS2 Services in Python. So next step is to open the ROSject. Click here on open the ROSject, and that's it. So, as always, this might take up to a couple of minutes or something like this to load. It needs to load. Now it's starting an Ubuntu 18 machine with ROS2 Eloquent and other things. So it needs to set up all the environment. Then, meanwhile, this is being started. As always, I'm going to talk a little bit with you guys. So yeah, in this case, I want to talk about a new course that we published last week, brand new course on our Ignite Academy. So let me log in real quick here let me come to the Academy real quick. Here we go. So here I'm in the Academy. Then, yeah, so last week I already talked to you about a couple of new courses that we had. Let me see. I can see them here. No, here we can see the free courses. Let me look. Okay. Yes, you know, this is a very new platform. So recently, like a month ago, something like that, we have updated our environment in the Academy. Yes, so still many new changes that are going to be coming here, as long as new courses. So here we can see a couple of them. For instance, we have the Kalman Filters course, which I already introduced to you past week, I think it was. So super interesting course about Kalman filters. You're going to see the bias filter, Kalman filter itself, also particle filters, and how to use all these filters in order to in this case, to improve the localization of your robot. So super interesting course. As well, we introduced the robot dynamics and control course, also a super interesting course on how the dynamics work on basic robotic systems. So it would be a kind of introduction to robot dynamics about basic robotic systems. And last week also we introduced the basic ARM kinematics course. Yeah, so we are going to see how forward kinematics, inverse kinematics works in robot manipulators. Yeah, so also super interesting course. I really encourage you to have a look at them. Of course, we also have the basic kinematics of mobile robots course, which was already introduced some months ago, but also super recommended course in order to get a good basic knowledge on robotics theory. Yeah, so not only focusing on the ROS part, on how to create ROS programs, etc., but also on learning robotics theory. Yes, which later we are going to always be able to apply it to ROS. Yeah, so super important also to know the theory of robotics. So yeah, let me come back here and see if this has loaded. Indeed, it has. So here my environment has already loaded. I have here my Jupyter notebook, which is being started right now. Let's give it a few more seconds to see if it fully loads. Let me make this a bit bigger. And here I have it. Yeah. So as you can see, once the ROSject loads, you are going to have the Jupyter notebook automatically opened. In this case, it's containing the notebook for today's live class number 106. So all of you guys, once you have opened it and loaded the ROSject, you should see something like this. Yeah, this would indicate that you are in the right path. Then the next step is going to be also similar as we did in the previous live classes. In the last live classes, we are going to start our TurtleBot 3 simulation in ROS2. So yeah, first of all, have you been able to load your ROSjects? Let me know in the chat here. Felipe Rivas says, loading. Der Capute says, unfortunately, I'm only at my mobile phone, that I only follow the video. Okay, Der Capute. Okay, well, in any case, even though you are on your mobile phone, you are going to be... You can get the ROSject and save it for later and then just open it when you are home in your computer. and you are going to be able also to review the video, since it's going to be uploaded to our YouTube channel once this live class finishes. So Engineering Nation says loaded all good. Hi prof, hello Kevin, hello. All right, so let's keep going. Then once the ROSject has loaded, next step, as I have already told you, is going to be to load the simulation. So let's open a new shell right here, and let's start executing all these commands. Yeah, all these commands are going to help us, are going to set up the shell and the environment so that we can start this TurtleBot 3 Gazebo simulation. So first of all, I'm going to need to source the ROS version. In this case, it's Eloquent, since we are going to be working with ROS2 Eloquent, so we need to source the proper ROS version that we are going to be using. If I'm not wrong, in this environment we also have Melodic, yeah, but not interested right now. We are interested in ROS2 Eloquent. Next thing is going to be to source the simulation workspace, as you can see here, which is basically the workspace where we have all the packages and files related to the Gazebo simulation. So we need to source it so that we are able to use them. And next we are going to set up some Gazebo related environment variables, as you can see, some resources, also mod paths for the models so that it can get the proper models for the simulation. Finally, we are going to set up which kind of TurtleBot 3 we want to use. In this case, it's Waffle. And finally, once we have executed all these commands, we can finally launch the simulation with the below command ROS2 launch TurtleBot 3 Gazebo empty world.launch.py. So let me execute this command right here, and if everything goes as expected, we are going to see here in the Gazebo window a simulation like this one, with an empty world and a TurtleBot 3 waffle here in the middle. So in order to see if this works properly, I'm going to need to open here from the Tools menu a Gazebo window. Don't worry if you see some errors like these ones, they are expected, so don't worry. So here basically I'm going to need to wait a few seconds and see if the simulation properly loads here in my Gazebo screen. As you may already know from previous live classes, there are some issues still with loading these kind of simulations with ROS2. So maybe it's not going to work on the first try, but don't worry, we will make it work on the second try. I will explain you how to do it. Okay, so in my case it has loaded here at first try, as you can see. Yeah. Okay, excellent. So I have here already my Gazebo simulation loaded with the TurtleBot 3 robot. Yes. Then, alright, so what about you guys? Did it work on the first try? Or okay, let me see. How do you open terminal? Asks Daniel. Very easy. Here in the Tools menu, here at the top left corner of the screen, you click on the Tools button, and then here you have to select Shell. If you select this Shell option, you are going to open a new terminal. Yes, you can open as many as you want, or as you need. What else? In the left corner top, it worked also first try. Great. Daniel Molina es un nombre español. Okay, so I see Kevin is answering you in Spanish. Okay, that's great. It's working fine. Great, thanks Kevin. Looks good here. Okay, excellent. So we had the simulation working on the first try. Great. So we are all ready to start. Then once you have loaded the simulation, we can just minimize this and forget about this shell. Don't close it, because this shell is the one which is where the Gazebo simulation is running. So we are going to leave it here, but we are not going to be using it anymore, so that we can minimize it. Yes, in order to gain more space. And we are ready to go. So ROS2 services in Python. Okay, this I think this is something which doesn't go for this live class. We can just remove it. Probably it's here from previous live classes. So let me just remove this section here. Then we are going to start by creating a service server. Yes, then if you have worked already with ROS1, you might already have an idea about what a service is or how a service works. So basically a service is a program which provides a functionality for the robot. In this case, we are working with robots, so it provides a functionality for the robot, and we can call at any time this server. We can send a request to this service, and this service is going to return, it's going to do whatever it needs to do, and then it's going to return to us a response. Yeah. So basically services are always divided into parts. We have the service server, which is the main code, let's say. It's the program which provides the functionality. And then we have the other part, which is the service client. Yeah. This service client would be the program which sends a request to this service server. Yeah. So for instance, let's imagine, let's put an example. Let's say that our robot has a service which, when we call it, it's going to move 1 meter forward. Yes. Then we would have a service server which provides this functionality. It has the code in order to do so. And then we would have a service client. Then from the service client, we will execute this client. And then this client would send a request to this server. Then this server would receive this request. The robot would start doing the service. In this case, it would move 1 meter forward. And then when it finishes, it will return a response to the client saying, hey, everything went great. Yes, and then the client would receive this response and do whatever it wants with it. Yeah, makes sense. So basically this is the main idea of a service. However, there are some particularities in ROS2, differences in ROS2 from with respect to ROS1, which we are going to see later in the live class. So for now, let's keep like this introduction and let's keep working. So first of all, what we are going to do is to create our service server. So for that, first thing I'm going to do, in a brand new shell, I'm going to source ROS Eloquent so that I can start using ROS2 commands. Then I'm going to go to my ROS2 workspace using this command in this case. Always, if I want to create a package, which is our case, remember to go to the src folder of your workspace. Yes? Then once I am here, I'm going to execute this command in order to create my package. I'm going to create a package named my service. As you can see, it's a Python package, and I'm going to add as dependency rcl-py. So let me execute this command, and this is going to automatically generate my package. Yes. Then now what I can do now is to open here as well in the tools. I can open an IDE, which is going to open my graphical development environment. Yes, so that I can visualize all my workspaces, all my files, packages, everything that I do. I can visualize it in a graphical way, which is always easier to work with. So in this case, I'm going to open the ROS2 workspace, which is the one I am working currently at, and I can see here that a new package has been created. This my service package, which currently it's empty. Well, it has some files which have been automatically created, but it doesn't contain any code. So here I have my package created. Great. Then now what I'm going to do is to create the script which is going to contain my service server code. Yeah. So for this, I'm going to come inside the my service folder, which I have here, the one which contains here an init.py, and here I'm going to create a new file, which I'm going to name server.py. Yes? Remember, guys, remember that I want you to be doing and practicing with me. Yes? So, with the exception of, I don't know who it was, the Capute, I think, which was in the mobile phone, and he has some difficulties to do all this. But for the rest, if you don't have any good enough excuse, I want you to be practicing with me. Yes, so everything I do, I want you to be doing it with me. Then let's go. So I have created the file, I have it empty, and then I'm going to copy and paste the code that I have here. So here I have a code, I'm going to copy, Ctrl+C, and paste it here into my file. Yes? There we go. So, what else? Okay, so now I have created my script, so next thing is to prepare my package in order to compile and generate an executable from my script. Yes, all these we already covered all these concepts in previous live classes, so I'm not going to go over them right now. So I'm going to open the setup.py file, and I'm going to add, in this case, the following line, this one, inside the entry points console scripts. So let me make this bigger so that I can see it better. Then inside here, I'm going to paste this line, which is going to create this service node executable. Yeah? All right, so far so good. Then next step is to compile my package. So let me come back here to my shell. I'm going to go to the proper folder. Remember, in order to compile, we need to be in the root folder of our workspace. And I'm going to execute colcom build command. There we go. It's compiling, it has compiled. Then once it finishes compiling, I'm going to source the install folder, the setup.bash file. There we go. Okay, so I have created my code, I have compiled it and generated the executable, so now I am ready to run my code. Yes, however, before running it, let's have a look at the code. Yeah, so let's have a look at what we have here so that we can understand what we should expect from this service. Yeah, so in this case here we can see some imports. Yeah, we are importing RCLPy as always that we are working on ROS2 with Python. We are importing as well the node class as always, and we are importing the set bool message. Yeah, in this case in ROS2 this is called interface. Yes, but this is the equivalent of the message for the service. Yes, so from the std srvs package, I'm importing this set bool message. Yeah, then here I am creating my class, which I am calling here live class service, LC service, which inherits from the node class. And then in the constructor here I am creating the service. Yeah, so I am using this create service function, which I am passing first the type of message that this service is going to use, second the name that I'm going to give to this service, in this case I'm going to name it my service, and finally I am passing the name of the callback function for this service. Yes, then here I have defined this callback function. So what is this callback function? Well, it's very easy. When a client makes a request to my service, makes a call to my service, this callback function is going to be triggered. Yeah, it's that easy. Then, as you can see here, in my callback function, I have as arguments the request of the service, which is the request that the client is going to send to me, and I have the response, which is the response that I'm going to send back to the client. Yeah, so I have these two arguments. Then, first of all, what I am doing is, from the request, I'm getting the data variable and I'm storing it here into this on-off variable of my class. Yes, don't worry if you don't know now where this comes from. We are going to see it in a moment. Yeah, just see that from the request that I'm receiving from the client, I'm accessing this data variable and I'm storing it into my own variable of the class, which is named on-off. Then I'm going to check the value of this on-off. In this case, I am checking if this on-off value is true or false, as you can see. Yeah, so this gives us an idea that this data variable it might be a boolean. Yes, because here I am checking the value of it. In this case, I'm checking if it's true or false. Then, if this variable that I have got here from the request, it's true, I'm going to set my response message variable to on. In case this variable is false, I'm going to set my message variable from the response to off. Then, as well, from the response, I'm going to set this success variable to true, and I'm finally going to return the response. Yes? So pretty simple. There might be some things here that you don't understand, but don't worry, you're going to understand them in a moment. Then, finally, we have the main function. As always, I initiate my node, I create an instance of my class, I call here the spin function so that my service keeps running, and finally I have a shutdown here in case I terminate my program. Yes? So far so good. Then let's run it and let's see a little bit more about this service, and let's try to understand some more things. So now I'm going to run my service by executing this command I have right here. Yes, then let's go for it. ROS2 run my service node. Okay, I got an error here. Attribute error. Type object type has no attribute type support. This might be a ROS1 message type, but it should be a ROS2 message type. Okay, it's possible that you also get this error. It's possible that you get it, it's possible that you don't. If you don't get this error, no problem. If you get this error, you just need to come down here to this nodes section, and you're going to see here an export command, which it's setting this Python path variable. Yeah, so just come here, copy this export command, paste it here, yes, and then run again the program, and it's going to work. Yeah, so in case you get this attribute error as well, just come here to a notebook and copy paste this command you have here in the notes section. Yeah, then let's come back up here. So okay, so now I have my service running, it has worked and it's here running. Yeah, then let's try to interact. First of all, let's try to know a little bit more about this service and interact with it from the command line. So I'm going to open a new shell here. Then, first of all, we have a command which is ROS2 Service List. If I run it, ROS2 Service List, it's giving me an error here, ROS2 command not found. Okay, so does somebody know why I'm getting this error? Can somebody tell me? Can somebody help me here? Source, okay, yeah. So I see that you already have this dominated, mastered, yeah? Okay, so I need to source this, pt ROS eloquent setup.bash. Another option, just for you to know, yes, if you don't want to keep sourcing every time you open a new shell, a good option would be, for instance, to put this source into the bashrc file. Yes, so bashrc files in Linux, in this case, are files which are executed whenever I open a new shell. Yes, then here I have many commands which are executed in order to set up the shells. So, for instance, I could come here to the bottom of this file and add somewhere here this source, yeah? Source, opt, ROS, eloquent, and whatever. Yes? Then in this case, if I do this, whenever I open a new shell, this source would be automatically executed, so I wouldn't need to do it. Yes, I'm not going to do it, but I'm just letting you know that this is an option, but I don't want to do it because this way we get this concept of the sources. Yes. All right. So I have sourced ROS. Then now I can execute ROS2 service list. Then this command, what it's going to do is to show me a list of all the services that are currently running or available. Yes, as you can see, we have some services here related to the camera, to Gazebo, Robotics publisher, also to the TurtleBot 3, different services, yes. So currently I have all these services available. But let's check, let's have a look and see if our service, which is named my service, is amongst them. So let me filter all these results and look for the service my service. And I can see that indeed it is here, yes. So somewhere here, yeah, in fact here I have it, yeah. Okay, so yeah, my service, which is running in this, no, here I have the simulation, here I have the service running, yeah. So the service which I have running here, it's working and it has started this service named my service. So far so good. Then, oops, sorry. Then what else? So another command I can use is this ROS2 service type. So let me execute it here. ROS2 service, service type my service. There we go. So this command, as you can see, what it does is that it returns me the type of message, the interface that my service uses. Yes. So as we already know from the code we have reviewed, we knew that our service uses the setBool interface. So we can confirm here with this command that our service it's using the setBool interface. Yes. But what about this setBool interface? So how it is? How does it look? Okay. So for this we can use another command, which is ROS2 interface show. Yes. We can execute this command here, ROS2 interface show, and then we put the name of our interface, which is this one in this case. Yes, std services survey setBool. Then this command is going to give us information about this specific interface. So we can see that it contains two parts. Yes, so the interfaces for services are the same as the services itself. So they have two parts. Yes, in messages, in interfaces for topics, we only have one part. Yes, so messages are have only one part. In this case, service messages have two parts. As you can see, they are separated by these three dashes. Yes. So the part which is above these dashes is named the request. Yes. So this is the part of the message which is going to be sent from the client to the service server. Yes. This is named request, and the part which is below these three dashes, it's named the response. Yes. In this case, here you can see two messages. Then the response is the part of the message which is sent from the service server back to the client once the service has finished. Yeah. So we have, in this case, the setBool message has one variable in the request which is of type bool, and it's named data. Yes. So if we come back here to the callback of our service server, we can see that we are accessing here from the request of this message, we are accessing this data variable. Yes. Then this data variable from the request is no other thing than this variable. Yes. Then once I have done whatever I want to do in my service, I return a response, and the response has two variables. Yes, has two variables, the response. One is of the type bool and it's named success, and the other one it's named message and it's of type string. So in my response I am defining the message variable, and I am also defining the success variable, which, as you can see, it's a bool. Yes. So this is where all this comes from. Yeah, you need to know which interface you are dealing with in order to be able to create programs for it. Yeah, makes sense? All right. Then let's keep going. So now, with all the data available, we can try to do a call to our service using the following command. Yeah. So now we are going to actually send a request to our service server. We are going to do a call. We are going to call our service server. Yes, and this is done with the following command: ROS2 Service Call. Then we specify the name of the service we want to call. We specify the type of message that it's going to use, set bool in this case, and finally we specify the request that we are sending to this service. Yes, in this case, the request, which is this bool data variable, it's going to be true, as you can see here. Yes, so we are setting that data variable to true. Then we are going to be sending this request to the service my service. Yeah, makes sense? Then if we send the request data variable as true, as we can see here, this first condition would be met. So the response message is going to be set to on. Yes, therefore I should receive from my service a response with success set to true and message set to on. Yeah, so I'm going to perform this call here, and as you can see, I made a request sending the true Boolean value, and I received as response the success variable to true and the message to on. Yes? Then instead of true, I sent a value of false. I'm going to receive a message, the message as off. Yeah, as you can see here. Okay, so far so good. So currently what we are doing is to send a request. We are calling our service from the command line tool. Yeah, this is valid, and in fact it's a very good option, especially when you are trying to debug issues. Yes, if you are trying to detect some problems, to test how your robot works, what services it has, this is a very good option to do all this from the command line tool, because as you can see, it's super fast and super easy to do. However, for more complex programs, it's going to always be required, or be better, to create your client into a Python script as well. Yeah, so this is what we are going to, well, first of all, remember that as always, we also have, you can check which options you have here for the ROS2 service command, adding here the H suffix. Yes, and here you see the different options you have, etc. Then now what we are going to do is to create a service client, as I have just said, within a Python script. So I'm going to do, so here I have already sourced this shell, so it's not needed. Then I'm going to basically directly go, well, not required as well. We don't need to create a package. In fact, we are going to use the same package. So all I'm going to do here is to, inside the my service folder, I'm going to create a new file. In this case, I'm going to name it client.py. There we go. And I'm going to paste this code here. Yes, so Control C, Control V. Next, I'm going to prepare everything in order to compile it. So let me get this here. And let me open the setup.py file and add here. In this case, I'm going to create an executable named client node. Yes, from the client py script here. So let me compile this. Let's go to ROS2 workspace, call build, and source. Okay, so now we have created our client code and we have compiled it. Then, before running it, which is the next step we have here, let's have a look at the script. Let's have a look at what it contains. Let me close this. So here we have the script. Then, as always, I am doing the imports of RCLPy, Node, and setbool. Then I have here an extra import, sys, which you are going to see later what we are using it for. Then we create the class here named LC client, which inherits from Node. We create here the client, as you can see, using the create client function. And we need to specify here the type of message that we are going to be using, which is setbool, and the name of the service we are going to be connecting to. Yes, in this case it's my service. Then here I have a small while loop, which basically from the client it's calling this wait for service function. Yes, with a timeout of 1 second. So basically this what does is that 1 time per second I'm going to check if this my service is available. Yes, so this is similar as what we were doing here with the ROS2 service list. Yes, here in the ROS2 service list, that we check if this service is running and available. Yes, so basically this is similar as what we are doing here. So we are checking if this service is available. Why? Well, because we need this service to be running. If this service is not running, this client it's useless. Yes, because this client needs to connect to the service server. Then if the service server is not running, this client makes no sense. Therefore, we need to do a prior check to verify that this service is running. Yes? Then basically this is what we are doing here in this while loop, using this wait for service function. Then here what we are doing is to define this request variable, which we are initiating to setbool. As you can see here, setbool request. Yes? So this variable is going to contain the request part of the setbool message. Yeah? Alright, then here we have the function send request. What we are doing here? Well, from the data variable of the request, we are going to store here a bool of the first argument sent in the command. What does this mean? Well, this means if you know a little bit of Python, you know that this basically is going to get the first argument that we specify in the command. Yes, we're going to see later this better. And then here we are indicating this future variable. Yes, this variable is super important. We are also later you are going to understand better this variable, or you are going to understand why we use this variable. Yes, but basically, as you can see here in this variable, what we are storing is the call async function. Yes, so here from the client that we have declared here, we are using the call async function. What does this mean? This means that it's going to do an asynchronous call to our service server. Yes, then in this call we are sending the request variable. Yeah, okay, don't worry, because you will understand better later this variable and why this call async. Yes, because this is a huge difference from ROS1. In ROS1, as you may already know, services were synchronous. In ROS2, per definition, services are asynchronous. Yes, so here we have the first main difference between ROS2 and ROS1. So we are doing a call which is asynchronous. Yeah. Then here we have the main function. We are initiating RCLPy. We initiate our class, and we call the send request function. Yeah. Then here we have the main loop, where we are checking first of all that RCLPy is okay, so that the program is running. We add here an spins one and spin once, and then we are checking this future variable. Yes, so this variable, this future variable, is going to contain information about if the service has finished or not. Yes, we can check this with the done function. Yes, so this done function is going to return true if the service has finished, has returned a response. Yes? And it's going to return false if the service has not finished yet and has not returned a response. Yes? So we are checking if the service has finished or not. Then here we are capturing a possible... here we are capturing the response. So if done returns true, so if the server has finished and has returned a response, we capture, with this result function, we are capturing the response from the service server. Yes, here we are capturing an exception, an error in case it appears. Else, by the way, this so we capture the response, and then here we print it. Yeah, in this case we use the getLogger function, which is the ROS2 function to print. Yeah, so we are going to print this response. Yeah, so super important to understand from here. First of all, we are doing a call async function to our service server. Then we store this async call into a variable which we are naming future in this case. Yes. Then in the main loop we are going to check this future variable using the done function, which is going to return true in case the service server has finished, or false in case it has not finished. Yes. Then in case it has finished, we can access the response from the server using this result function as well from the future variable. Yes, and then we, in this case, we just store this result into the response variable, and we then print whatever we want to print. Yeah? In this case, we are going to print the message indicating the robot state. Yeah. And finally, we have the destroy node and the shutdown. Yes. Okay. Then let's execute it. For now, let's we have already compiled it, right? So let's execute it. Then, in order to execute it, we can use the bellow command. So ROS2 run, name of my package, name of executable as always, and as you can see here, I have an extra argument to my command, which is true. Yes. Then this argument is going to be captured here in this sys argv. This is going to capture the first argument, which in this case it's true. If we put another one, then this would be the second argument, and we could capture it as well, putting here a 2 instead of a 1. Yeah. In this case, we only have one argument, so we are going to capture the first argument. Let me remove here the second one. Yes. Then we are going to capture this true argument. We are going to convert it to bool, and we are going to save it here in the data variable as our request. So we are going to our request is going to send a true value. Yep. Therefore, if we are sending a true value, the response message should be on, right? Okay. Then so let's execute the command. Let's execute our program, and it's failing again with the same error that we had here. So I'm just going to copy and paste again this export Python path command and run again my program. There we go. And as you can see, we are printing the robot state is on. Yes, so we have done the call, we have sent the request, we have checked that the service server has finished, we have captured the result, and the result, it was on. Yeah, as expected. So now, if instead of true, for instance, we send as argument false, we are going to get a robot state of off. We should, at least. Let's see. It's not capturing this properly. Okay, I don't. Maybe this is because I need to write it like this. No, well, this is not capturing then properly the response. Okay, never mind. I will check it later. Okay, then. Okay, yeah. So far so good. Then let's keep going. Let's keep going because we have only 5 minutes left, and here comes the important part. So until now, here we are working on an asynchronous call. Yes. Then. So what does this mean basically? This means that I can perform a request, and meanwhile the service it's doing whatever it needs to do, I can do other stuff. Yes? So I only need to keep checking this value, the future variable. I need to check if it has finished or not, but meanwhile I can keep doing other stuff. So I'm not blocked when I send the request. Yeah, this is why it is an asynchronous call. Yeah. However, in Python, in ROS2 Python, because I believe that in C++ it's not possible. I'm not sure though, but I think it's not possible. But in Python, it's possible to also perform synchronous calls to a service. Yeah. So it's possible to do a synchronous call. Then, a synchronous call will block the calling thread when sending a request to a service until a response has been received. Yes? So, in a synchronous call, basically I'm going to be blocked until my server returns the response. I won't be able to do anything else. I'm going to be blocked there. Yes? Nothing else can happen on the thread during the call. Then it is very easy to mistakenly cause deadlock when calling services synchronously, so it is not recommended to use this kind of calls. Yeah, so the best practice, the recommended practice it's going to be always to do asynchronous calls. Yeah, this is the recommended practice. It's not recommended to use synchronous call. However, since they are there, I think it could be interesting to add them here. So I'm going to just show a quick example of how a synchronous call would be. Then on the other hand, as we already saw in the previous section, an asynchronous client will immediately return future, a value that indicates whether the call and response is finished, not the value of the response itself. Yes? So yeah, this future value contains, it's going to tell us if it has, if the service server has finished or not through this done function. Yeah, but it doesn't contain the response itself. So we need to access to the response also using this result function after sending a request to a service. Yes, then let me get a drink here. In order to use a synchronous call to a service, we will need to use the call function. So first of all, we are not going to use anymore this call async function. Yeah, so this is the first thing. Then let me just comment this here. So we are going to use this function here. Let me copy it and paste it. Yes, so we are going to use the call function instead of the call async. Yes, this is the same. We are going to send the request the same, but instead of using the call async function, we are going to use the call function, and we are not going to store anything in any variable. Yeah, so we are going to directly return here the value because we don't have this future value anymore. Then, in this case, let me take out all this, or well, So this is the key part of the program. So let me just comment it so that we still have it here. I'm going to just comment it like this. There we go. Then we are going to need to make use of the thread function in order to do the service call in a separate thread. Yeah, so this is super important. So first of all, we are going to need to import this thread module here. So let me add it here in the imports section. And then I'm going to need to use this as well. Yes, so where do I have the request? Here. So before the request is done, I'm going to need to do this. Yeah, so basically here what I am doing is to create a separate thread here for RCL by spin. Yes, why? Because my request is going to be blocking. Yes, it's going to be blocked. So therefore I cannot have RCL spine, which is also blocking, and do a request in the same thread. Yes, therefore I need to create a separate thread here, in this case for RCL by spin. For doing this spin, I need to do it in a separate thread. Yes, so this is basically what I'm doing here. I'm creating a thread here for the spin, and I'm starting it. Yes, then in the other thread I'm going to call the send request function, which is going to perform the asynchronous call. Yeah, then yeah, so I can store then here this. So this function is going to return me here the response, directly the response from the server, so I can store this value here in a variable, in a response variable, and then with this response, basically what I can do is to use this function here in order to print from the response whatever the response I receive. Here, in this case, I'm going to print the message variable from the response. Yes? So, let me have a look at this. So, yeah, I think that's it. So, use the call function. We need to start a separate thread for doing the spin here on the RCL by node. And then we call request, we store it in a variable, and then we print if we want. In this case, we are going to print the message variable from response. Yeah? So, let me try to compile this one more time. I think I did everything right. So, true. Okay. Okay, yeah, so as you can see, we still receive here the response. In this case, we are doing an asynchronous call. Yeah, so basically, my program here in this case will be blocked here until I receive a response. Yes, as a difference to what we had here previously. Yes, where we could do other things while the service was still working. Yeah, in this case, this service is super simple. So basically, we cannot almost see here the delay or anything. But the idea is this one. Yeah. So yeah, basically that's it. Let me have a quick look here at. Hello everyone. Engineering Nations says if ROS2 has async services, does ROS2 still have actions too? That's a very, very good question. Yeah, because in ROS1, as you already know, services were synchronous while actions were asynchronous. Then if ROS2 services are asynchronous, Are there still actions? Are they still used? Yes. The answer is yes. So either running it with the argument false and it still returns on. Yes. So, yeah. So I saw this. I saw as you saw also happened to me. I don't know why this was happening, but yes, engineering. This is a very good debugging practice for later. So I encourage you to have a look and see why that is happening. Probably a very stupid mistake there. But answering to your questions, yes, ROS2 still has actions. And when now maybe you would ask, then when should I use services and when should I use actions? Because ROS2 actions are also asynchronous as services. Then what is the main difference? Well, as always, it depends on you, as always. But the main difference is that actions also provide feedback. Yes. So if we call a service in an asynchronous mode, we are going to be able to do other things, but we can only know if the service has finished or not, so that we can get the response. Yes. In actions, we also have feedback. Yes. So from an action server, we can return feedback to the client. So my suggestion, or what I think it would be better, is to use actions in the case our process or our service or our server in this case has to do something that is going to take a long time. Yes. So let's imagine that we are going to call a functionality of the robot which is going to take 2 minutes. Yeah, let's say I'm going to call a service which is going to activate a drone, which is going to take off, do a full rotation in order to get images, and then it's going to land. And all that is going to take for 2 minutes. Yes? Then, since that action or service is going to take that long, I would be interesting, or I would be interested as a user to get some kind of feedback from the server, to know how it is going, or to know something. Yes. So in that case, I would suggest using actions so that I can make use of this feedback that actions have. In other cases, in very quick actions like the one we have been using here in this example, which is it's very quick. Then in this case, it's better to use services, because it makes no sense in this case to use an action. Yeah. So basically, that would be my answer. I'm not an expert again in ROS2. I am still learning ROS2. So yeah. In this case, I'm a student like all of you guys are. So I'm still learning, and there are many things I still need to learn about ROS2, and there are many things I still need to practice to have a better knowledge. But from my noobish point of view right now, I would say that. And if you need the continuous feedback and not just the final response, yeah, that's it. That's it, Engineering Nations. Yeah. All right. So okay. Oh my God! Already 8 minutes. 8 minutes past the time. Okay. So we are going to end it here, guys. So one more time, thank you very much for. Let me change here the screen. So one more time, guys, thank you very much for being here with me on this live class number 106, where we had a small review here on ROS2 services, how they work. We created some Python scripts for clients and services. We also checked a few command line tools that we can use in order to debug services. Also some differences, like we were talking right now about services in ROS2 and ROS1. So yeah, I think it was a very complete live class. So one more time, thank you very much, guys, for being here with me. Without you, this would not be possible, and these live classes wouldn't exist. So thank you very much, and I will see you next Tuesday with next live class, which I don't know yet what is going to be, but It's going to be something very interesting, I can tell you that. So yeah guys, thank you very much. Until then, until I see you again next week, take care as always and keep pushing your ROS learning. So bye bye. What are you doing, Alberto?
I'm training this intern with ROS.
Oof. Did you have the same experience? Spending too much time equipping your team with ROS skills? Check out our ROS Online training solution for enterprises. A fast and easy way to empower your team with ROS. From ROS basics to manipulation, perception, AI, ROS2, everything your team needs to learn is here. Practice with real and simulated robots. Train your team by doing from day one. Also, our ROS experts will provide you 1 hour of consulting services to boost your robotics projects. Want to become a happy Alberto? Request a demo today.